we are going to discuss about overheat detector with auto cutoff system using operational amplifier. Myself Madhumita and this is my team Nikhil, Ramanathan, Nisha and Mahalakshmi.
Let's discuss about our project. As we know, our project is overheat detector with auto cutoff system. We are using operational amplifier LM358 which has two inputs, non-inverting input and inverting input. We are using potentiometer to give the reference voltage to, and we are connecting that into an inverting input, and we are giving thermistor to the non-inverting input. When the temperature of the room is in normal condition, the LED is always on. When the temperature increases, the resistance of the thermistor automatically decreases. When the resistance decreases in the thermistor, the operational amplifier's voltage is produced very high. The LED is always on in the normal temperature. When the temperature increases, the thermistor resistance automatically decreases. When the thermistor's resistance decreases, the operational amplifier's voltage increases. When the operational amplifier voltage increases, the transistor works as a switch to the relay kit, where the relay kit is responsible for the on-off process of the LED. When as we know, LED is always on the normal temperature. When the temperature increases, the LED automatically turns off, and it turns back on when the system is cooled back. So this is our circuit. I'm gonna explain this. So we have used operational amplifier IC, and we have connected the potentiometer and thermistor to it. We have used a battery over here, and we have used relay kit. As you can see, the light is always on in the normal room temperature. When we increase the temperature near on the system, it automatically goes turn off. So let me show you how. So when we heat the thermistor, as you can see, the light is turned off, and it turns back automatically on when the system cools down. See, as you can see, the light is turned on back automatically when the system cools down.